Okay, so now it's recording. I gave you a few so you could process the information, but you probably want to go back and do some more. And I'll also provide you a way to do that, okay? The reason this is up there, I don't know this is exactly your view. I don't think you have this graded thing out there, I'm not sure. But anyway, I just want to make sure that you know that now I think a lot of y'all are used to open it, it just says homework and then under that it says test. Anyway, your info for the test is down here when you go to the page, okay? When you click on it, this is just a good starter study guide. Back to, we will have half angles. Don't let Mr. Hill's students get in a tizzy about that because they probably had it on their other tests. We all have it on their exam anyway, but don't let them freak out and oh my gosh, we have half angle if you're studying together, okay? Log signs and cosines and area of a triangle and trig form of a complex number. These two worksheets you already have. I've just provided blank ones, and today I'll pull some into my presentation. And this one's awesome. You will love this one, but I'm going to wait till Nicole gets back because I want her to see that. So there she is. Okay, so these you already have. I'm going to go in and open them because I will use some of them.
Elena's in the bathroom.
Oh, thank you. Okay. So now we're kind of waiting on her. All right, so let's go to half angle. By the way, on two of the worksheets that you're provided, you have a spelled out example, okay? You do have choices when I ask these on the exam test. When I ask these on the test, you actually have a choice of if you want to go rogue and go off on your own and memorize the half angle identities, you can do that. I showed you one day that when I memorized the half angle identities, it's really not a whole lot less work than just doing what I'm showing you here. This is real important to emphasize in what you're doing in calculus anyway, and so I like this method. You should certainly from your quizzes, a girl, one of my AP students taking her test this morning in DC, and she's like, I really need, the double angle identities, and I'm like, Mom jumped out of my chair and pulled her hair, okay? Yes, you need to know your double angle identities, you need them for A, B, and B, C, and you need to recognize them. That's why we make you memorize them. If you haven't memorized them, you won't recognize them. Anyway, having said all of that, I'm not going to do this example because that's spelled out for you, okay? But I'll do one of these. So what I'll say on the test is use the half angle identities, not just find cosine of 105, because they just leave it hanging out there. Find cosine of 105 degrees. You'll probably use the sum and difference identities, okay? Which will give you the same answer, it'll just be in a different form. I will say explicitly, use the double or half angle identities, okay? I use the double because my argument way back then, you may have forgotten it, is that the double angles are also the half angle identities, okay? These are double that, but by the same argument, what are these compared to that? They're half of it. So I feel like I'm not going to learn anything new. I'm going to stop there, okay? Which is where your memo page stopped. So by the way, now that I'm thinking about this, in addition to memo quizzes throughout the year, we're also going to have a few times where we have kind of like a spelling bee. And, maybe the team left standing or the person left standing. I hadn't figured out how it's going to do it because I hadn't seen spelling bee in a long time. But where your rapid fire sine of 5 pi over 6 is 1/2 kind of stuff. And so be thinking of what prizes you want, because all I would want would be chocolate candy, but you might not, like a big bag of M&Ms or something. But if maybe I can go buy some stuffed koalas or whatever.
Or a 100 memo quiz.
Now I don't want to give a homework pass. I think that's just going to hurt you.
A 100
I mean, back in the day, but my homework is so relatively small compared to the work that you need to. I'm not going to give a homework
I
pass.
think a 100 memo quiz.
Yeah.
Yeah.
No, I'd rather eat candy.
Maybe I'll have some choices.
I'd rather get candy.
Okay, so I'll have some choices. So, a what? A good sandwich. Okay. Send me ideas so that I can.
Candy idea.
Like, how they have the exchange days and they bring exchanges for final lunch and they have those liquid sandwiches?
Oh yeah, I think I do know.
Or like the NHS thing.
Send me requests. Okay. Anyway, test. Next time I see use test, so let's keep moving. All right, so I'm going to do the sine, I'm going to do the cosine of 105. Oh, these are, yeah, thanks to Lauren. Yeah, all right, so, all right, so cosine of 105 degrees. Girls, if I'm doing the half angle identities, which you'll have to do, there is a way, like if you've memorized the big square root over 2, this one's like 1 plus sine of, anyway, I don't use that one. If you want to memorize them and practice them, they're all in your textbook. Easy to look up half angle identities. I don't push them because in calculus, I just use the double angle as my half angle. All right, so anyway, I'm thinking that 105 times 2 is 210, and I'm like, yay, I know 210 degrees, okay? So I'm going to start off with cosine 2a. I have 3 choices. I'm hardly ever going to use this one because I don't, a lot of times, know sine and cosine. Using the Pythagorean identities, changing this into 1 minus sine squared gave us this one, which you've used and reported to me on your quizzes. Or if I change sine squared behind the minus sign, that gives me 2 cosine squared a minus 1. Okay? So since I have cosine of 105, I'm going to choose this one. Right now, a is 105. Okay? So I'm going to have the cosine of 2a, 105, equals 2 cosine squared a, which is 105, minus 1. Then I would obviously multiply and have cosine of 210 equals 2 cosine squared 105 minus 1. Cosine of 210 is negative square root of 3 over 2 in the third quadrant 30-degree angle. I'm going to add 1. I'm just doing algebra now, just the next logical step. When it was logical for me to find that number. Then it was logical for me to add 1. Then to me, if I ever have fractions, it's logical to get a common denominator. So this would become 2 minus root 3 over 2. I changed this to 2 over 2. 2 minus root 3 over 2. Now, if I divide by 2, that's pretty ugly, so what could I do instead? Multiply by what? So I'm going to multiply both sides by 1/2 equals cosine squared of 105. So I have 2 minus root 3 over 4 equals cosine squared of 105. What's your next logical step? To find the square root, in which case you say plus or minus. So I have cosine of 105 is equal to the square root of 2 minus root 3. And what's the square root of 4? I can pull the bottom out as 2. And 105 is in which quadrant? So it's definitely a choice of a negative. Choose. My again, in AP Cal, my students are in a position right now where they're also having to choose in a different situation, plus or minus. And some of them are forgetting that. There's a reason that you pick one or the other. Your teachers have said plus or minus, not plus and minus. So anyway, there's another example spelled out for you on the sheet. And I'm sure you've got that sheet somewhere, or you can work it. And you'd be glad to answer any question, but couldn't you also always check your answer? Type it in cosine 105 and take notes. So you can make up your own and check your answers or use mine. Now, if you have radians, like for instance, if I want to find like the sine of pi over 8 or pi over 12, all right? What is 2 times pi over 8? Isn't that pi over 4? So I'm going to say cosine 2a equals 1 minus 2 sine squared a. So whatever goes here is doubled here, and you'll know that number. I've gone this far, I might as well keep going. Question, Chloe?
No, why is it cosine instead of sine?
Okay, I'm always going to use the cosine 2a formulas.
Okay.
Always. I'm always using the cosine 2a formula because I can turn it into this or this. Does that answer your question? Okay. If I use the sine 2a formula, I've got like a multiplication that I can't undo.
Okay.
Here you can work with it. Plus these we need to know really bad. Okay, cosine of pi over 4 is root 2 over 2 equals 1 minus 2 sine squared pi over 8. I'm going to write really messy so we can move on quickly. I think I would add this to the other side and subtract this. It's because I don't like negatives. So this side becomes 2 minus root 2 over 2. And you get sine squared pi over 8 equals 2 minus root 2 over 4. Is that okay? If I multiply this by 1/2. A square root. Pi over 8 is definitely in the first quadrant. And so I would get the positive answer. That would be the sine of pi over 8. So whatever I give you on this section that says use the doubled or half angle identities, whatever I give you will always be half of something that you could put on the other side. So let's move on. That's so long ago. I just want to make sure I talked about that. Very, very important identities. All right. So now let's look at this. Okay, that was that one. So is that the same? Okay. Here, let me go in. Is everybody here? Okay. The reason I was waiting until everybody was here, back. Oh, never mind. Okay. So let's go to law of sines and cosines. Did I already open? Okay. You know, on the law of sines and cosines, Mr. Hill and I will make out the test together, but they may look different depending on what all we tell our students. We'll definitely have half angle. You might have one of your angles in your trig form of a complex number might have degrees, minutes, and seconds in it, like some of your homework has, whereas I don't know if they've learned that. But whichever one of us, usually what happens is one of us makes out the test, and then sends it to the other one, and they like work it and verify it between myself and Mr. Hill. And then we also tweak just a tiny percentage of it to fit what our classes are used to seeing. So I think if Mr. Hill, if I make it out, which I don't know if that'll be me that does the first draft, but mine will obviously have boxes for the sine and cosine. If they're not used to seeing that, they need a lot of these boxes here, okay? And so anyway, yours will have like boxes on it, okay? Because that's where I want your answers. I think you have this sheet, but apparently it's coming out really funny. I need to repost this as a PDF because I remember when I gave it, some people's was missing. So if I don't remember to do that sometime today, I know during lunch I have a math team meeting, then I have class, and I'm meeting with a student, and then I might forget. So if somebody just shoot me an email, and I'll get a PDF of this.
Also, if you open it with like pages on your computer, it'll.
Okay.
So like you download it to your desktop. And then
Maybe I just let me try that. Okay.
challenge.
All right. So Grace, I got it here, and then
I like put it on my desktop, like my back desktop, and then I just right click it and then open with pages, and then like.
okay, because it doesn't do that on my other. Oh, look how tiny that. Okay, it was cute and little.
It
It
was
looked.
really cute.
Okay, and then what?
Right click it, like, and then open it.
I'm right clicking. Oh, open with
Pages.
pages. Thanks, Grace. Okay, so now I need to. Oh well, I'll fight with it later. Okay, so so let's look at number 3 and talk about how we would do number 3. And I tell you what, let's just look at these. This first one, I'm going to use law of signs, but on my boxes, let's see, it was 104. Oh, sorry. 104, 10, and 12. Okay. So help me remember that. C is 104. Did I give you A is 10? And C is 12? Okay. If I had given you A is 18 and C is 12, let's talk about some scenarios, okay? So you don't get bogged down in this part of the test. This one would be no triangle.
Yeah.
Raise your hand if you know why. All right, Nicole?
Well, the hinge theorem says that like the largest side is across from the largest angle. So if 18 is the largest side and C is smaller than that, and C already has an obtuse angle, that means A would have to have an obtuse angle, which would be greater than like.
There's no way for that to happen. If you don't notice it at first, you'll run into error on your calculator work. Obviously, I want my calculator in degrees for law of sines and cosines, so be careful. Okay, but on the thing it said this, 10. So this would only have one triangle. I could cross out the second one. Y'all did a great job on your quiz. Oh, by the way, I think I have stuff to hand back to you. Have I handed back these quizzes?
Yeah.
Okay. I think I have some memo page stuff to hand back to you then. If you feel like you're missing something, you can say after class, and I'm not going to take time to do that now. This is a 12. What I would want you to write in the box is you're going to find angle A first. Then you'll subtract to find angle B, and that'll dictate little b. You could do all your work, around as neatly as you want. And if you get all of these right, then I don't have to, it's just nice for me to check the box, okay? Do you see why there'd only be one? Okay, Bella?
Oh, I was just gonna ask.
Okay, because I already have an obtuse angle, okay? And law of sines can only find what kind of angle, girls? Acute. And so I'm super safe because the other one can't be obtuse, okay? All right, now,
You know what was really attractive was the raw snitch.
all right,
Throw it out there.
this one, okay, girls, in your boxes, this could only have one triangle, if any. If I give you two angles, there's no ambiguity. There's only one thing the third angle can be. Ambiguity can only happen, the ambiguous case can only happen if you have given one angle. You're going to use the law of sines, and that one angle is acute. All right? That's the only time it can happen. So you can, I think you have all the answers to these. If not, you can check with me. All right, let's go back to the sheet. All right, number 2 could have two triangles. So let's look at it. Number 2 could have two triangles, and we'll start this one. So maybe I can copy this. I don't know if it'll go into my notebook or not. No. Oh, it's there. Let's put it on another slide. All right. So this one could have two triangles. All right, so and I'm going to use law of sines. I'm not. I'm sorry. Why am I not using law of sines here? What makes my decision automatically to use law of cosines?
Well, because you don't have like the A, like lowercase a.
If you have three different letters, you're using the law of cosines. Okay? And as Pietra said, even if I started out to use law of sines, I would get stuck. I wouldn't have enough information. So she and I are definitely going to have to start off finding little a. Now, we talked at length about this, girls. You might remember today that I actually worked through a law of cosines and I missed the problem, but we felt like I was working it completely right. That's because I switched over to the law of sines to find an angle that could have been obtuse that inverse sine can never tell me. Okay? So, the next thing after you find little a few girls in here, I can't remember who, but a few of my students actually, Katie, I think you just stick with law of cosines the whole time. It seems like, and you're super safe. And just practice that if that's what you do. Law of cosines cannot mess you up. Again, the reason for that is when you're doing a squared equals b squared plus c squared minus 2bc cosine a, or one of the other forms of that, you're doing all this adding and subtracting. So you could end up with a cosine that's positive, or you could end up with a cosine that's negative, couldn't you, if all of it transpires in a way to where you still have a negative? Well, arc cosine is conclusive on triangles. It will check up to 180. It will check quadrants 1 and 2. And it's positive in quadrant 1 and negative in quadrant 2. So do you see it? They will be very conclusive. All right, just a quick word, because you probably want to talk about trig form of a complex number. But just real quickly here, if I'm going to switch over to law of sines, I would find angle B next, because which is the only angle in this scenario that can be obtuse? C. So if these were switched, I would still find the one opposite 12 first if I'm going to switch to law of sines. Because I'm thinking to myself, like Chloe said, there might be an obtuse angle in this. And if I switch to law of sines to find little c, it will never know. It won't even check for me. Law of cosines is conclusive. So this was pretty safe. I know angle B is what? Acute. So I can switch over to law of sines, and once I find that, they have to add up to 180, so I know the third angle. But just be careful, because we tend to go in order that we see the numbers. So just pause for a minute and look at it. Okay? All right, so, and make sure you're in degrees on that part. I'll even try to remind you on test day of that. Okay, so, what are other slides? We've got these red ones. All right, so now, I'm sure someone else has gotten up and gone to the bathroom, but I've been trying to get everybody here. The other thing I think you'll really like that I gave you, in addition, you should be old enough now to look at the examples in the book. They're really, really good. You can cover them up and work them after you read them if you're struggling with something or want more practice. But also, this just gives you more examples, and I found this earlier today, and I love it. Review of complex numbers, so they remind you how to do everything. And then they go into trigonometric form of a complex number. I think if I'd given you this on the front end, it would have been overwhelming. But on the back end, you can see what they're doing, and they explain everything. If you get caught or lost, this is great. A lot quicker looking at a video. But I've sent you many. If you haven't watched any, that's fine. But I've worked homework problems. I've given you heads up. I usually try to title them all the way back to when you needed them. But this is really easy to look at. And then you have products and quotients. And then you have somebody that speaks, is that French? Say that word for me. Demois? Anyway, that guy's Demovry. That's probably about as bad as I'm really doing it when I'm trying to say Demois. Okay, so anyway. They're doing this, like how to raise it to the fourth power. And we may come back to this one if we have time today. and then roots of a complex number with examples. I thought this was great. I don't know who did it, but we're thankful for it. I think it's a really good review that you can look at. I wouldn't say this is all you need to do. We'll probably work this problem. Or one like it. I know that y'all want to see a square root before we go, or a fifth root, or a whatever root. There was something I was going to say. Oh, I wouldn't say those 3 attachments are all you need to study unless you look at those 3 attachments and go, good, I got this. How you really should use any study guide, which is what I call them, is like if you're stumbling through law of sines and cosines, that study guide flags that you better go back and study some more material that I assigned, or same for any of it, okay? All right, so, one more thing. I also found this that I have opened up for you. So I wanted to say it while everybody's sitting here, because it's not really explicitly on the, oh, I didn't realize how late it was. I have, if you go to student view, this is what you'll see. Nth roots of complex numbers, and if I click on that, you would find the 4th roots of 625, and you could even, if you wanted to, you could look at, show solution or whatever, okay? Now I'm going to try to do one really quickly, just to talk about some quickness of it. Thank goodness I did make that video last night, because I didn't foresee how long the quiz would take today, so you do have that to look at. But girls, hold really still for a minute. If I have 3 plus 3i to the 5th, my 2 options are to do 3 plus 3i times 3 plus 3i times 3 plus 3. I don't want to do that. Trig form of a complex number is so wonderful because I can find the angle. I believe the r would be 3 root 3. And this is definitely in the first quadrant. Always think about that. So I would have cosine of pi over 4 plus I sine of pi over 4, whatever that is, and raise all of that to the 5th power. And so you say your r to the 5th, and you multiply it times those, and you're done. Okay? All right, now what if you wanted the 5th root of something? Like if I have x to the 5th plus 125 equals 0. Okay? I have x to the 5th equals negative 125. So I'm looking for the 5th roots of negative 125. If you graph this on your graphing calculator, you would get by transformations an x to the 5th graph that would be way up at 125. You would only get one real 0. I'm moving really fast, but from your polynomial study, that may make sense. By the fundamental theorem of algebra, there are 5 things that make this 0. There are 5 under the complex number system, which you can't see that purple word. But anyway, if one of them's real, what are the other 4? Imaginary, and imaginary numbers come in pairs, so that makes sense. So now with the way that we find a root, you can actually find all 5 of them. Now, I think it's actually 1125. So I will probably do what I did the other day. I think it would be very helpful to fast forward to the very end of this video